want to continue on with motion maps. What we want to do here is get a motion map from a position time graph. We talked about in class the 4 ways that you can represent motion. Those 4 ways to represent motion are position time graphs, words, which is the obvious one that everyone forgets, velocity time graphs, and then motion maps. What we want to be able to do at some point is to translate between each one of these. Go from a motion map to a velocity time graph to words, words to a position time graph. So we're kind of working up to being able to translate between all of these. So what we want to do is we want to take this position time graph and we want to convert that to a motion map. What I think I would do first, very first thing is, I noticed that I've got several different motions here, so I would go ahead and see where the game is changing here, and just kind of make a little mark for myself to remind myself that I've got 3 separate motions going on here. And what I might do, and actually I am going to do, is I'm going to go ahead and identify these motions before I try to create my motion map. In other words, I'm going to convert to words right away. Might help me put together my motion map. This first motion here, that first motion is moving towards, steady, and I've got another slope here that I can compare to. This is definitely moving slower than this because this slope is less steep than this slope. So I'm just going to go ahead and call that slow since I do have something to compare with. The second motion here, the ever recognizable standing still, because my position isn't changing throughout this time frame. And then the last part of the motion is still moving. Ooh, did I say towards up above? That's not moving towards. Oh, yes, it is. I take that back. This is still moving towards. Yeah, it's moving towards because it's getting closer and closer and closer to our zero, to our origin starting point. Towards, it's still steady because I've got a straight line, and this is fast compared to this up here. So we've got this set of motions, and what we're going to do is we're going to go ahead and convert this into a motion map. Now we don't have any numbers to work with, but that's okay. We don't necessarily need numbers. Here's my 0. And again, I'm going to make a number line essentially. What I notice first is that this is not starting at 0. So my time 0 is not going to be located at the origin. That guy is not at 0. So we're not starting at the start. My initial time is going to be out here somewhere. So I'm going to call this time equals 0. I'm not at my start back over here. Now I'm heading towards at a slow, steady speed. So I'm just going to go ahead and make a couple, whoops, I'll keep it the same color. I'm going to make a couple of dots here to represent my position. At this point I can tell that I'm moving towards steady. Maybe I'll go one more. So at this point, I can tell that I'm going towards steady. I keep getting closer and closer to the origin, just like I did here, closer and closer to the origin. So at this point, I can start standing still. And again, I want to stack these. And what I might do, sometimes what I do for myself is, I'll talk about how I know these are going to be evenly spaced when I go to make my motion map. These are going to be stacked. And then these are also going to be evenly spaced but wider. So these are close. These are evenly spaced, but wide. So at this point, I went ahead and stacked, so I'm good there. And now I can start moving back towards the origin. And again, this time I want to go wide. So I went 1 there. I think I'll jump to 2s. So this is wider than the other one. Oops. Again, I want to stick with the. There we go. Stick with the color that I originally used. So I go here. This is definitely moving faster. And there we go. And I could even make one more, although I didn't get down to 0 here. Just extend that, say it is to 0, and there we go. I'm at the 0. Now I'm not done with my motion map yet. What I need to do is fill in my velocity vectors. I know that these are all going to be the same length, and these will be shorter than these that I put in here. So again, to get from this position to this position, this had to be moving. It had to have some sort of velocity, so I give a velocity vector. And since these are all evenly spaced, these guys are constant. So that's why it's evenly spaced. And these arrows are all the same length. I've got my standing still portion where these are stacked, and then these are going to be longer. Again, from here to here, there is no velocity. I don't put an arrow on here. It's in the same position. It doesn't move, so I just leave it. Same thing to go from here, this position to this position. It's the same position. Can't be moving. It's got to be, no velocity vector here. But to get from this position over to this position, it definitely had to be moving, so it had to have some sort of velocity. So this guy does get a velocity vector. Again, at the end, we don't know what it's doing after this point. It could continue to move on, past the origin, could pass where it started. I usually just give it the same motion that it's been moving with prior to this. Oops, that's too long. Let's try that again. That's 1, 2, 3, 4, 5. There we go. And that's our motion map. So again, a couple of things to keep in mind. When we converted, I think the first thing I did was I converted to words. Translate into words first. Put down a few notes about the starting point. And position spacing or dot spacing. And then I made the map. Hopefully this is helping.